Welcome everyone. In this video, we're going to graph cosine function. So the general form of the cosine function, it's usually written in this way, or the standard form, you can think of it, where you have A here, which represents the amplitude of the cosine function. Then this K right here, this gives you the frequency, meaning how many cycles are you going to complete in a period of 2 pi. And then this B right here, we know that is our horizontal shift. Or you can call it the phase shift as well. And the C right outside here, it's called the vertical shift. So just like we know from transformation, now we're going to apply it to the basic cosine function. So let's go ahead and take a look at the basic cosine function, how it looks like. So from the unit circle, we know that cosine graph looks like this. So we're going to draw one period and then we'll extend it. So cosine has an amplitude of 1. So we go above 1 and below -1. If you want, you can draw these horizontal dotted line to scale your graph, but these are not so important. But I'm going to do it here since this is the first graph I'm sketching. And cosine completes one period from 0 to 2 pi. So you subdivide this length into 4 subinterval, 1, 2, 3, 4. So each of these will have a length of pi over 2. So this is pi over 2, this is pi, this is 3 pi over 2, and then 2 pi. And same thing repeats on the left side as well, but let's just focus on one period. So cosine starts at 1. So at 0, cosine is at 1. At pi over 2, cosine is at 0. At pi, cosine is at -1. 3 pi over 2, cosine is back to 0. At 2 pi, we're back to 1. So that's the graph we get from the unit circle. And then the cycle repeats. If you want, you can copy and paste to another period. Let's go for 4 pi. So that's another 2 pi. Subdivide this into 4 subinterval. And you can just repeat the period. So here is going to be at 0, then -1, 0, back to 1. So another cycle. And just keep on repeating more and more periods. But the focus point is always from 0 to 2 pi. This is one period for cosine graph. So from this graph, we can write down some basic information. So this is the graph of y equals cosine of x. So you can see the amplitude is 1. That's the number in front of cosine. And k value is the number in front of x. That's also 1. So frequency is 1. And b, there's no horizontal shift. There's no c. So this is what we call the basic cosine function. So the amplitude is 1. We know the frequency is going to be 1. We can call that k. That's 1. And the period, the formula for period is going to be p equals 2 pi over k, because k tells you how many cycles you're going to have in one period. So since k is 1 in this case, it's going to be just 2 pi. Let's go ahead and graph this function. So if you were to recall the standard form or the general form, we know our function has to be written in a times cosine of some k times x minus b plus c. So let's identify these. So a is this number right here. So we know that the amplitude of this function is 2. And k is this number right here. So the frequency is going to be k, which is 3 in this problem. And that will help us to find the period. So we know the period is going to be p equals 2 pi over k. So that means this is 2 pi over 3. So we're going to complete one cycle, that wave that we saw in between 0 to 2 pi over 3. So let's go ahead and find the interval for one period. So let's call it interval for one period. So you know where to complete one cycle. It's going to be from 0 to 2 pi over 3. Because the period is 2 pi over 3, we're starting at 0. So from 0 to 2 pi over 3. Now let's go ahead and subdivide this interval into 4 subintervals. So we know on the x-axis, our axis looks like this. So from 0 to 2 pi over 3, we're going to complete one cycle. So we need 4 equal length interval, so we can find these points and then we can make the same shape. So we know the shape will look like this. It's going to start up here, go down here, go down to -1, 0, and back to 1. That's the usual cosine. Now here the amplitude is 2, so instead of labeling this at 1, we're going to label that 2, and below we can only go -2. So that's where the amplitude comes in. Now to fill in this question mark, we need to find what's the length of each of these interval. So pretty much you take the interval, the period, 2 pi over 3, and you divide that by 4, because you need 4 equal length of interval. So this will give you 2 pi over 3 times 1 over 4, and then this will simplify to pi over 6. So the length of each interval is pi over 6. So you start counting. The first point is going to be 0, and then plus pi over 6. That's right here. And then 2 pi over 6. And then 3 pi over 6. And 4 pi over 6, that simplifies to 2 pi over 3. I can also simplify 3 pi over 6. That's pi over 2. So this point right here is pi over 2. That's how you find the length of each interval. And now make the shape. So it looks like that. It looks just like that. So that's one cycle of cosine. If you want to draw more cycle, continue on. Just replicate this over and over, as many periods you want, but this is good enough for one period. So from here all the way to 2 pi over 3, we complete one period. That's one period of cosine graph. Now let's go ahead and graph this one. So if you were to match this up with our standard form, so we know our standard form is some function is equal to a times cosine of some k times x minus some b plus a c. So we know amplitude is this number in front of cosine. Since it's negative, you take the absolute value of it. So we know the amplitude, it's going to be absolute value of -1, which is 1. So the height is going to be 1. Now frequency, or the k value, for this problem, it's going to be, so this number right here, which is 1. So k is 1, which helps us to find the period of this problem. So the period is 2 pi over k, and that's going to be just 2 pi since k is 1. So nothing changed from the general cosine graph. And this b right here is this one right there. So since it's negative pi over 4 inside the parentheses, we have a horizontal shift of pi over 4 to the right. So that means our x coordinates are going to shift to the right by pi over 4. So we'll talk about that a little bit later. Now let's go ahead and find the interval for one cycle. So the interval for one period, it's going to be from 0 to 2 pi before doing the shift. Now when you shift, so after shift, the interval for one cycle, it's going to be, so you add the shift to your interval right here. So you shift everything. So that means 0 plus pi over 4. You're going to start at pi over 4, and then 2 pi plus the shift. So you'll get your interval for one period is pi over 4 plus 2 pi plus pi over 4. So that's going to be 9 pi over 4. So that's how you can find the interval for one cycle once it's shifted. But let's go ahead and draw this first, where we complete one cycle. Now also remember this negative right here. That's going to reflect the graph about the x-axis. So this negative is going to indicate a reflection over the x-axis. Now let's go ahead and put all of these together in a graph. So let's go ahead and draw the cosine graph. So first we're going to draw this one, negative cosine of x, and then we'll shift. So here's how negative cosine of x would look like. So we know that the period is 2 pi, so it's the usual cosine, but it's reflected. So let's call this 2 pi. So subdivide this into 4 subintervals. So here are the points. This is pi over 2, this is pi, this is 3 pi over 2. And we know the amplitude is 1, so let's call this 1, And let's call this -1. So instead of starting up here at 1 and then preserving the shape, instead we're going to start from -1 since it's a reflection. So we're going to start here, hit 0, and then go to 1, and then hit 0, and then come down to -1, and then create that wave. So this is how that shift reflection would look like. So let me redraw it so that it looks smoother with a different color, perhaps. So here is my cosine graph that is being reflected. So this is negative cosine of x. Now we're going to, so you see how you have one period from 0 to 2 pi. That's the interval. And now we're going to shift this pi over 4 units to the right. So the new interval for the shift is going to be pi over 4 to 9 pi over 4. So we need to find the new x coordinates. So you're shifting all of these x coordinates. So this one, this one, this one, this one, and this one. All of them pi over 4 units to the right. So what we're going to do is going to find the new x coordinates. So 0 gets shifted pi over 4 units to the right. So we're going to start at pi over 4. And that's what we got right here. That's the first point and the last point. So that's the first point, and then the last point has to be that one. So we'll verify that as we go along. Now let's find the middle point. So the next point that we're shifting is pi over 2. So we take pi over 2 and add pi over 4 to it. So put them in common denominators. So you'll have 3 pi over 4. That's the next new x coordinate. And then pi will get shifted pi over 4 units to the right. So that's going to give us 5 pi over 4. And then 3 pi over 2 gets shifted pi over 4 units to the right. So that would give you 7 pi over 4. And then the last point is 2 pi. That gets shifted pi over 4 units to the right. So that's going to be 9 pi over 4. And you see how the first point and the last point matches with the interval we came up with. That's where we should have one cycle once it is shifted. So all of it makes sense and it's coming together. So let's go ahead and plot these points. So I'm going to use a different color to show you the shift. So my first point is pi over 4. So pi over 4 is right here. So that's going to be this point right here. And then pi over 2 gets shifted. So then 3 pi over 4. And that's going to be somewhere right here. So this is going to have this point. And then 5 pi over 4 is right here. And then the next point, it's going to be 7 pi over 4 and then 9 pi over 4. So 7 pi over 4 and 9 pi over 4. And just recreate the point. So here's the next one. Here's the next one. Here's the last one. And we make the shape. So here's our cosine wave for one period. So from here to here, this is one period. So you can see the length is going to be 2 pi, and the interval for one period is pi over 4 to 9 pi over 4. So the red is representing our final sketch, which is negative cosine of x minus pi over 4. So the red is negative cosine of x minus pi over 4. All right, so this is it. I hope this makes sense.